So, welcome back. We are going to look at the linear search, the searching operation that can be done in an array. Okay. So we had visited this linear search in our previous classes. We'll just look at the steps in the linear search. A simple approach to do linear search is you start from the leftmost element. Okay. So see this. What is the size of this array? How do you declare this array? You would have declared it as int a of 9. Okay, so it will have 9 locations, 0 to 8, and it has all the values. Okay, and if you see, they are unsorted, right? In linear search, you can always do it with an unsorted array. You start from the leftmost element of array, and one by one you compare. For example, if the value to be found, or if your key is 20, you compare the key with the first, this one. 20, is it equal to 10? No. You move to next. 20, is it equal to 50? No. 20 equal to 30? No. 20 equal to 70? No. 20 equal to 80? No. 20 equal to 60? No. 20 is equal to 20. So that means your search is successful. However, had you had an element like, say, for example, 8, your search will be unsuccessful till the end, and you will say search is not found. If you imagine an array of size 1000 and you're going to search an element that is not there, your time complexity will be very high. You will have to do 1000 operations on an average to ensure an element is there. Okay, so this is the disadvantage of linear search. I'll just run through the code of linear search for you. Okay, if you look at linear search, for example, you can say enter the number of elements in the array. So ampersand n, you can enter the elements one by one, a of I. Then you can say the key that you're going to search as ampersand key. You are going to traverse the entire array for I equal to 0, I less than n, I plus plus. If that a of I is equal to the key, then you say element is found. Okay. Else you say element is not found in the above array. Okay. So we'll just run this program. I think a previous program has not been closed. Yeah. Okay. So we'll run. Enter the elements in the array. Say, for example, I will go with 5. My numbers are 9, 19, 29, 39, 49. Okay. Now enter the element to be searched. For example, if I say 39, okay, it's found, right? It says element 39 is found at location 4. Okay. So I can even run an element that is not that. For example, enter the element number of another 5, 9, 19, 29, 39, 49. Okay. I want to search the element 59. So the element 59 is not found in the above array. Okay. So the next concept we will see is the binary search. Okay. So in the binary search, a search in a sorted array by repeatedly dividing the search interval in half. Okay. First time you search, you find some answer, you again limit it to the next half. So begin with an interval covering the whole array. First you cover the whole array. If the value of the search key is less than the item in the middle of the interval, narrow the interval to the lower half. Otherwise, narrow it to the upper half. Repeatedly check until the value is found or the interval is empty. Okay. So in simple terms, compare x with the middle element. If x matches with the middle element, we return mid index. Else, if x is greater than the mid element, then x can lie only in the right half subarray. So we recur for right half. Else, if x is smaller, we recur for left half. So this we had seen with that guessing number game that we saw in the first class. Okay. You consider an array of size 10, index from 0 to 9, and the elements 2, 5, 8, 12, 16, 23, 38, 56, 72, 91. Okay. You say lower is equal to the 0th index and higher is equal to the 9th index. So obviously the mid will be 0 plus 9 divided by 4. That is mid is equal to 4th location. Okay. You want to search the element number 23. You want to search element 23. So first, when you check the mid and your key, you find they are not equal. But however, you find that the mid is less than key. Since mid is less than key, the lower becomes mid plus 1. So now the lower becomes 5. Right? So now lower is 5 and high is 9. And now your new mid is 5 plus 9 divided by 2. That is 14 by 2. That is 7. So now your element is, now your mid is 56. Now you compare this 56 with your key and find your mid is greater than the key. So what you do immediately, high is mid minus 1. So in the next thing, low is equal to 5 and high is equal to 6. Now you calculate the new mid. Mid is equal to low plus high divided by 2. So that is 5 plus 6 divided by 2, that is 5. So now your mid of 5, that is mid value is 23. 23 is equal to 23. Therefore, the element is searched. In binary search, you limit your search space in half in each and every step, but the precondition is it must be sorted. Okay, a small comparison: time complexity is O of n for n elements in linear search, whereas it is O of log n for n elements. Best case O of 1 first element. In binary search, if the element is in center, it is the best case. So O of 1 for center element. Prerequisites: linear search doesn't require any prerequisite, whereas the array requires it to be in a sorted manner. Implementation are, it can be implemented as an array and linked list. Binary search cannot be implemented as a linked list because linked list is sequential access and array is direct access. So therefore array is done. The algorithm type linear search, it is iterative. You repeat from 1 to n, right? Whereas in binary search, you divide it into two halves and you conquer. So we call that as divide and conquer. Okay. And I wanted to summarize with the two arrays. Okay, so I have taught you how array is represented in memory. Okay, we had seen it in that PDF file. Okay, how array is represented in memory, right? So this is the way array is done in memory, and I'm sure you also would have recollected the row major and column major concept. Just two pointer examples for you to understand. Okay, so this is a very simple program. Okay, so it says int I star ip a of 10. So ip is equal to a. What happens? Ip is equal to a. So ip gets the base address of a. Since a is an array, it is treated as a string, and simply you can put ip equal to a. Had a been an integer like integer a, you should have put it as ampersand a. Okay, then what happens? For I is equal to 0, I less than 5, I plus plus, a of I is equal to 100 plus I. Okay, so normally the value will be 100, 101, 102, 103, 104. Then you just put printf check, and then you say for I equals 0, I less than n, printf I less than 10, right? Only for 5 you have initialized values, but you're going to print till 10. That means from 6 to 10 you will have some garbage value. So printf star ip plus 1. This is another representation. So first it will print star ip, the next time it will print star of ip plus 1, next time it will print star of ip plus 2. Okay, but when you talk about that plus 1, it will jump in terms of size of int because it is integer. Okay, had it been float, it will jump by 4. Okay, right. So we'll just run this program and see whether the discussed output is correct. Yes. Okay, so initially it's prints check, and then as we discussed, it will print 100, 101, 102, 103, 104, and then 5 garbage values. Okay, so this is a program. And another program that I wanted you to know was just an insight into pointers. Okay, you say int num of 5 is equal to 3, 4, 6, 2, 3. Then I say int star p equal to num. So now star p will point to the base address of 3. Then star q equal to num plus 2. So now star q will point to the base address of num plus 2, that is plus 2. So it will point to 6. Okay, then again star r is equal to address of num of 1. So star r will point to address of 4. So now what will be your answer? Can you tell me? Printf backslash and percentage d number of 2 star num plus 2. Can you key it? Yeah, come on. I want you to key all these 3 lines. 4 lines we have. What is num of 2 and star number? You know num of 2 is 4, right? Is num of 2 4? Somebody tell me no, yeah. Oh my God. It's 6. Yes, correct. It's 6. Very good. So number of 2 is 6 and star num plus 2. I said these two are equivalent, right? So again star num plus 2 is 6. Now I say star p. What is the value of star p now? Come on, type it. What's the value of star p? Star p is equal to num only they are saying. So what is star p? 3. Good. So it will be star p plus 1. So it will be 3 and 4, right? The next thing is star q. So what is star q? Star q is num plus 2. So what will be the answer for star q? 6. Okay, so it will be 6 and 2, right? The next thing is star r, that is address of a number of 1. So star r will be 4 and 6. So let us run this and see whether we have discussed is correct. Yes, right. So it is 6 6 3 4 6 2 4 6. Okay.